Hi students, I am your Nagini ma'am, chemistry mentor. In today's section, I am going to teach you an excellent trick to find an aromatic, anti-aromatic, non-aromatic compounds, organic chemistry 11th class. Okay, after this session, students, you will feel very happy to answer the questions based on this topic, students. Okay, now we'll start Nana. Aromatic compounds. First of all, aromatic compounds. See here, aromatic. Aromatic compounds are classified into two types, Nana, benzenoids, non-benzenoids. Okay, so here classified into benzenoids, two types, benzenoids, non-benzenoids. Non-benzenoids. Okay, benzenoids, non-benzenoids. So benzenoids means aromatic compounds which contains at least one benzene ring in them, understanding. So that means aromatic compounds, they contains at least one benzene ring, those are called benzenoids. That means they contain benzene ring. Are you understanding? So it contains benzene ring, it contains benzene ring. Non-benzenoids, they do not contain benzene ring. Clear? They do not contain benzene ring. Do not contain benzene ring. These are called non-benzenoids. The aromatic compounds which do not contain benzene ring, those are called non-benzenoids. Which contains benzene ring, those are called benzenoids. So non-benzenoids also belongs to aromatic compound, students. Are you understanding? So aromatic compounds means only benzene ring compounds, only aromatic, not none. So non-benzenoids also belongs to aromatic compounds. Keep in your mind. Understanding benzenoids. For example, benzenoid, see here. This is benzenoid. Take just one benzene ring. This is benzenoid compound. Are you understanding? This is benzenoid compound. Now if you take non-benzenoid compound, non-benzenoid, this is non-benzenoid compound. See here, is there any benzene ring here? No, it is a just cyclic structure. Understanding? It is not a benzene ring. So, which do not contain benzene, those are called non-benzenoid. So, it is a non-benzenoid compound, but it is belongs to aromatic compound, students. It is a cyclic compound. It is a every carbon undergoes sp2 hybridization. That all conditions we will discuss later. Understanding? So, this is about aromatic compounds. So now I'm giving excellent tricks, students, for aromatic, anti-aromatic, non-aromatic. See here, first we are going to discuss conditions. Okay, aromatic, anti-aromatic, non-aromatic. First one condition, aromatic. We'll discuss aromatic conditions. Aromatic compounds. What is the first condition? First condition means cyclic. The compound should be cyclic. Okay, that means ring structure, it is a closed structure, cyclic. The compound should be cyclic. Next one, second one, each carbon should be sp2 hybridized. Each carbon should be sp2 hybridized. Clear? So this is the second condition, sp2 hybridized. That means which shape, students? Planar. So the compound is planar means we can say that the compound is aromatic compound, but we cannot say planar structure, students, here, because whatever the structure we are writing on the paper, that is 2D structure. Actually planar is the 3D structure. Understanding? 3D structure. So that's a by seeing the structure we cannot identify the given compound structure is 3D or 2D. Understanding? So that's why just you have to check only the compound, given compound is cyclic, or next each carbon is undergoing sp2 hybridization or not. Once you check it, understanding, students? So this planarity we cannot say, students, we cannot identify. So leave it this one. Clear this one. Each carbon sp2 hybridized. Sp2 hybridized, that means here alternate double bond should be there. So that conjugated system, for example, double bond, and next double bond, sigma double bond. Next one, double bond sigma lone pair, double bond sigma positive charge. Understanding? So like this, there means the ring structure, double bond sigma double bond, that means this is the conjugated system. They link with one another. Understanding? Double bond sigma, lone pair, double bond sigma positive. So like this, there means we can say that each carbon is undergoing sp2 hybridization. Okay, no? So next condition, coming to the third condition, here Haeckel's rule. It should satisfy the Huckel's rule, students. Understanding Huckel's rule. So here Huckel's rule, 4n plus 2 pi electrons. Aromatic compound should satisfy 4n plus 2 pi electrons. Okay, pi electrons. Just you don't need to here for this formula also no need to use, students. Just you remember electrons in a 2 pi electrons, 2 pi electrons. Next one, just add 4, 2 plus 4, how much? 6 pi electrons. Clear? 6 pi electrons. 6 plus 4, 10 pi electrons. Next, 10 plus 4, 14 pi electrons. Just difference 4 will be there and so on. So these number of electrons are there in the given compound. So we can say that the compound is aromatic compound. Understanding? Only this much only you have to remember, students. Clear this one? So first is condition what? Cyclic. The compound should be cyclic. Each carbon atom should be sp2 hybridized. These are the conjugated system. These conjugated systems are there in the given compound. We can say that the compound is aromatic. Okay, now next electrons. Here electron should be 2. Here difference should be 4. Nana. 2 plus 4, 6. 6 plus 4, 10. 10 plus 4, 14 pi electrons. Understand? These number of electrons there means that is aromatic. Now coming to the anti-aromatic. See here, anti-aromatic. Second type, anti-aromatic. What about anti-aromatic, students? First condition, cyclic. The compound should be cyclic and each carbon atom should be sp2 hybridized. And third condition here, not Huckel's rule, students. Here 4n plus 2 pi electrons rule. This is 4n pi electrons rule. Understanding? It should satisfy 4n pi electrons rule. So here you don't need to use this formula, students. Just you remember number of electrons. See here, number of electrons, 4 pi electrons. 4 pi electrons. Next, plus 4. 8 pi electrons plus 4, 12 pi electrons and so on. So these number of electrons are there means in the given compound, that is anti-aromatic. Are you following? So only just you remember, students, these three conditions, cyclic, sp2 and 4 pi electrons. Understanding? Now coming to the non-aromatic. Third one, non-aromatic. See here, third one, non-aromatic. Non-aromatic. So non-aromatic means the compounds which are neither aromatic nor anti-aromatic. Understanding? So the compounds which are not aromatic, not anti-aromatic, those compounds are non-aromatic. Understanding? Clear this one. So what is the definition? Non-aromatic, students? Compounds which are neither aromatic nor anti-aromatic. Clear? Anti-aromatic. So that compounds are non-aromatic. Understanding, students? So any condition in aromatic, anti-aromatic is not satisfied, that is non-aromatic, students. Compounds which are neither aromatic nor aromatic, so those are non-aromatic, students. Okay, so just you remember, students, these three points: cyclic, each carbon sp2 hybridized, and here these number of electrons aromatic. Okay, now we'll go to discuss example, students. See here. Okay, listen. So here different model examples are there. See here, you can easily calculate, students. You can easily identify the given compound is aromatic or anti-aromatic, non-aromatic compound. See here, I will discuss here some examples, students. Here, see, we'll do fast. See here, first example. See here, the given compound is which one? Aromatic, anti-aromatic, non-aromatic. And see here, the compound is cyclic. It is a closed structure. Yes, it is a closed structure, so it is a cyclic. First condition satisfied. Next one, what? sp2 hybrid. Each carbon atom should be sp2 hybridized. See here, what is the conjugated system? I told you. What is the conjugated system? Double bond, sigma, double bond, sigma, lone pair, double bond, sigma, positive charge. Understanding? See here, conjugated system. Conjugated system is nothing but sigma pi. Alternate double bonds are there means that is conjugated system. Understanding? See here in this example, this is pi. sigma positive. Pi sigma positive there means what I told you. Pi sigma positive means each carbon is undergoing sp2 hybrid. See here, pi sigma, here there is no charge. Here pi sigma sigma, again sigma sigma is there. Are you following? See, understanding students. So here sigma, here sigma, that means same bonds side by side should not come, Nana. Understanding? See here, this is sigma, this is sigma, single bonds kada. This is pi bond, this is sigma, this is sigma, this is sigma. Are you following? Single bonds represent sigma bond. So sigma sigma, sigma bond side by side came means that is those are not in the conjugated system. Are you following? So not conjugated, not conjugated. Next, coming to the electrons. Find out electrons, pi electrons, students. How many electrons are there here? Only 2 electrons. Okay, pi electrons, how many? This is pi bond now. Pi electrons means 2 electrons, 2 pi electrons. Are you understanding? It is not conjugated. So one condition is not satisfied. That's it is which compound, students? How many electrons? 2 pi electrons, 2 pi electrons there. But it is not conjugated now. So not conjugated means what we can say? Not conjugated. So that's why it is non-aromatic compound. Are you clear? This is non-aromatic compound. Clear? Non-aromatic compound. Now coming to second structure, see here, it is cyclic. Yes, it is cyclic compound. And second one, conjugated system, there are not. See here, pi sigma negative. Negative indicates lone pair. Negative indicates lone pair. Okay, see here, pi sigma lone pair, sigma lone pair, sigma pi bond. Understanding? So same bond not repeated. Are you following? They are in the conjugation. Pi sigma lone pair. See here, I told you already, pi means double bond. Pi sigma lone pair. Pi sigma lone pair. Clear? So here this is pi sigma lone pair, pi bond sigma lone pair, sigma bond lone pair, sigma bond lone pair. So it is in the conjugation. Are you following? It is in conjugation, right? Conjugate. How many sigma, how many pi electrons are there? Count here. Here pi electrons 2, here lone pair, this lone pair. Total in each ring, students, maximum 6 electrons should be there. Understanding? 6 electrons, 6 pi electrons. So here 2 only there, this 2 also, they are participate in the conjugated system. Just you have to count it. Just you remember, students, count the electrons, number of electrons over here 2, here 2, here 2. Total how many electrons? Bond means 2 electrons. 2 plus 2, 4. 4 plus 2, 6 electrons. Yes, 6 pi electrons are there. 6 pi electrons there means what? The compound is which one, students? See here, 6 pi electrons there means what I told you. 6 pi electrons, aromatic compound. Are you following? 6 pi electrons. See here, cyclic satisfied, sp2 hybridized. Here the conjugated system, here which one is there? Double bond sigma lone pair is there, satisfied. And next here 6 pi electrons are there. So that's why the given compound is which one? Aromatic compound. Clear this one? So our given compound is aromatic. Understanding? Given compound is aromatic. Now come here, do it fast, do it fast. Third structure, see here, it is first one cyclic. Yes, cyclic, and it is closed structure, cyclic. And next one, it is in the conjugation. This is double bond, pi sigma, pi sigma, again sigma, sigma sigma, side by side there. So that's why it is not in the conjugation. Are you following? Same bond should not be side by side, not conjugation. Understanding? So they are not conjugated. So that's why it is which one? Non-aromatic. If they are in the conjugation, that is aromatic or anti-aromatic, we can say. If it is not there in the conjugation, so we can say directly non-aromatic. Are you following? This is non-aromatic. Okay, next compound, see here, do it fast. It is cyclic. Yes, cyclic. And second one, it is in the conjugation, pi sigma. This is pi bond, pi sigma positive. Next sigma sigma pi bond. So it is in the conjugation. Yes, okay, conjugated. Next one, how many electrons? 2 pi electrons, 2 pi electrons. That's it is given compound is aromatic compound. Are you following? It is aromatic compound. Clear? Aromatic compound. Do it fast, do it fast. Next, fifth one, just I'm using shortcuts, students. See here, it is cyclic. Yes, cyclic. And here it is double bond sigma lone pair, sigma double bond sigma. So here same bond not repeated, all are in the conjugation. Next one, how many electrons? Here 2, here 2. Here negative charge means 2 electrons. So here pi electrons 2, here 2 electrons. Total 4 pi electrons. 4 pi electrons there means which compound this is one? See here 4 pi electrons there means what I told you, 4 pi electrons, anti-aromatic compound. Clear? For anti-aromatic compound. See here anti-aromatic compound. This is anti-aromatic. AA. Clear? Anti-aromatic. Understanding students that in the conjugation means that no need to check it. Each carbon atom should be each carbon atom undergoes sp2 hybridization. You don't need to check it. Okay, just that conjugated system you practice. Okay, next see here, next example. It is cyclic structure. Next one, conjugation. Pi sigma positive, sigma pi sigma sigma. See here single bond sigma side by side there. So that's why it is not in the conjugation. Are you following? So not conjugation, not conjugated. Okay, not conjugated. So that's the given compound is given compound is non-aromatic. Not conjugated means what? No, non-aromatic. The given compound is non-aromatic. Now do it fast. Next example, see here, it is cyclic. Yes, cyclic. Next here, see here sigma, here sigma side by side there. It is not in the conjugation, not conjugated. Clear? Not conjugated. Next one, not conjugated means which one? This one, non-aromatic. Understanding? The given compound is non-aromatic. Now coming to the next one, see here, it is cyclic. Yes, it is cyclic. Next one, conjugation. Here see pi sigma pi. Yes, alternative bonds there now. So that's it is in the conjugation. Next one, how many pi electrons? Here this is pi bond, this is pi bond. Bond means 2 electrons. 2 plus 2, 4 pi electrons. So 4 pi electrons there means what we can say? 4 pi electrons there means anti-aromatic. So the given compound is anti-aromatic. And coming to the next structure, see here. The given compound is cyclic. Yes, here see pi sigma positive conjugation. Okay, now they are linked with one another. Here sigma positive, sigma pi bond. So it is in the conjugation. So conjugation there, conjugated. Next one. Okay, now how many pi electrons are there? Here only 2 pi bond, only one bond is there. That means 2 pi electrons. 2 pi electrons means the given compound is aromatic. Clear? The given compound is aromatic. Now see here, do it fast. This is cyclic compound. Okay, next one, it is in the conjugation. See here, this pi bond sigma positive, sigma pi bond sigma, then sigma, and here again here sigma, and here sigma is there. Are you following? Sigma. See here, pi bond sigma positive, pi bond sigma, pi bond sigma, lone pair. Negative charge indicates lone pair. Okay, lone pair again sigma. Okay, na sigma, lone pair, sigma. They are not side by side. So it is in the conjugation. Next one, how many pi electrons? Pi bonds. This one, and these 2 electrons also involved in the conjugation. So lone pair of electrons you have to count it. 2 plus 2, 4. 4 plus 2, 6. So 6 pi electrons are there. 6 pi electrons means what? No. Which one? This is aromatic compound. Clear? Now coming to the next example. It is cyclic. Next one, cyclic compound, and it is in the conjugation, students. See here one lone pair will be there. Nitrogen now, valency 5 valence electrons. So here one lone pair. So pi bond sigma, lone pair sigma. It is in the conjugation. Yes, conjugation. How many pi electrons? Here pi bond, this is pi bond, lone pair. Total 2 plus 2, 4. 4 plus 2, 6 pi electrons. 6 pi electrons means it is the given compound is aromatic. Clear? Next structure you see. Next one, this is cyclic. Yes, it is in the conjugation. Yes, conjugation, pi sigma pi sigma, lone pair. So it is in the conjugation, right? Next one, how many electrons? Pi electrons. 2 plus 2. How many pi bonds are there? 1, 2, 3. This is pi bond. 3 bonds are there. 6 pi electrons. Each bond is having 2 electrons. So 3 bonds. So how many electrons? So 6 pi electrons are there. Are you following? 6 pi electrons. So that means you remember, students, in each ring maximum maximum 6 pi electrons should be there. Understanding? Here lone pair also should count. If you count lone pair, you will get 8 pi electrons. So it is wrong, students. Understanding? You should not count these 2 electrons. These 2 electrons not involved in the conjugation, students. Okay, now these 2 electrons are free electrons. It is ready to donate. Clear? So maximum 6 pi electrons will be there. So 2 plus 2 4, 4 plus 2 6 pi electrons. So it is which one? Aromatic compound. Clear? 6 pi electrons. Now coming to the next one, cyclic. Next compound, tell me, cyclic. Next, it is in the conjugation pi sigma. Yes, it is in the conjugation lone pair sigma. So it is in the conjugation, students. Next one, how many pi electrons? 2 plus 2 4 only there. That's why you have to count this lone pair. So 2 plus 2 4, 4 plus 2 6 pi electrons. Understanding? So this is also aromatic compound. Next, coming to the example, cyclic. The given compound is which one? Cyclic. Yes, cyclic, and it is in the conjugation pi sigma, lone pair sigma. So it is in the conjugation. Next one, how many pi electrons? 1 2. Okay, here two bonds are there, 4 electrons, and here one lone pair you have to take it. So 6 pi electrons are there. This lone pair you should not take, Nana. This electrons already here 6 electrons over, na. So this electrons not involved in the conjugation. They're ready to, oxygen is ready to donate that electrons. Okay, so 6 pi electrons. It is also aromatic compound. Now coming to the next example, see here. This is which one? Cyclic. So this is cyclic, and next it is in the conjugation pi sigma lone pair. Pi sigma lone pair sigma. See here sigma side by side there. So that's why it is not conjugation, not conjugated. Clear? Not conjugated means immediately it is non-aromatic compound. Are you following? It is non-aromatic compound. Now coming to the next example, see here. Here which one? This is cyclic, and it is in the conjugation, students. Pi sigma double bond. Okay, now here when you are doing this one, here one bond, here oxygen is more electronegative, it is shifted to here. Oxygen is will get negative, and here it will get positive. So carbon here positive, this is pi bond sigma positive. So it is in the conjugation. So conjugation is there. How many pi electrons, students? Only one. Here one bond is there. So 2 pi electrons. So it is an aromatic compound. Next, coming to the last example, see here. It is cyclic compound. Clear? It is a cyclic compound, and here it is in the conjugation pi sigma positive, sigma pi sigma. So it is in the conjugation. How many pi electrons? 2 bonds. Okay, 2 bonds means 4 pi electrons. Clear, students? 4 pi electrons. Next one, see here. Next one, see, Nana. See here, multiple rings. Multiple rings means polycyclic compounds. Polycyclic compounds. Fused ring, isolated ring. Fused ring means the 2 benzene rings. The 2 rings are linked with one another. That is fused ring. What is isolated ring? If the 2 rings are separated by the single bond, that is isolated ring. Clear? So now see here. This one here, double bond O is there. So how it is cyclic? It is which compound? See here, this bond is shifted to here. This will get negative, this will get positive. Now it is in the conjugation pi sigma positive, sigma lone pair sigma positive, is pi bond. So it is cyclic. First one, next one conjugated. How many pi electrons, students? Pi 2 here, and one lone pair. 2 plus 2 4, 4 plus 2 6 pi electrons. It is the aromatic compound. Clear? Next one, see here. Next example, here it is cyclic compound. It is in the conjugation pi sigma positive, sigma pi sigma. It is in the conjugation. How many pi electrons? 3 pi bonds are there. So 6 pi electrons are there. It is aromatic compound. Clear? And coming to here, see here, 3 benzene rings are there. It is anthracene, Nana. See here, it is cyclic compound. And next one here, it is in the conjugation. Yes. Next one, how many pi electrons are there? 1 2 3 4 5 6 7. So all the rings you have to count it, because 3 rings kada. So 1 2 3 4 5 6 7 bonds. 7 2s are 14 pi electrons. 14 pi electrons there means it is also aromatic compound. Clear? Aromatic. Now see here, in this compound, it is which compound, students? Here double bond is there, na? So double bond there means here you have to take here, whenever bond is breaking, it will get minus, it will get positive charge. Okay, minus or positive. Then here you have to take separately, Nana. Okay, in the fused compounds you have to take separately. See here, it is in the conjugation, pi bond sigma lone pair, pi bond sigma lone pair, right? It is in the conjugation, it is cyclic, conjugation is there. Here how many electrons? 1 2 3 6 pi electrons are there. Here also 3 bonds are there, 6 pi electrons. It is aromatic compound, aromatic compound. Understanding? It is also cyclic, cyclic, and next one it is in the conjugation, and it is 1 2 3 4 5 5 and 10 pi electrons are there. So 10 pi electrons there also, it is it is aromatic compound. Understanding? Isolated ring. See here, both rings are separated by the single bond. Single bond there means here it is cyclic compound, first condition. Second one is it is in the conjugation. Next one, here total 6 pi electrons are there, here 6 pi electrons, so here also 6 pi electrons. It is completely aromatic compound. See here, last question. See here, students, 2017 question. So which is the least stable compound? So first, stability, how to tell means here aromatic compounds are more stable. See here, you remember this one, aromatic compounds are more stable than, next one, non-aromatic. Okay, next one, anti-aromatic. Clear? So this is the stability order, students, because aromatic compounds here stabilized by the resonance structures, and non-aromatic, if you take non-aromatic compound, here the electrons are filled in the lower energy molecular orbital, so that's why stability is less, and here stability is very less. Okay, now just you remember this point, students, you can easily understand. See here, this one first, which is least stable means the compound. So first you have to identify it is given compound is aromatic or non-aromatic. Based on that you can say that stability. See here, it is cyclic conjugation, and it is 6 pi electrons are there. It is which one? Aromatic compound. And coming to the next, see here, this example B, it is also cyclic, it is in the conjugation, and 6 pi electrons are there. It is also aromatic compound. Coming to here, see here, here it is cyclic compound, it is in the conjugation. Total how many pi electrons? 1 2, here lone pair, total 6 pi electrons are there. It is also aromatic compound. Now coming to here, fourth example, see here, fourth one, here it is cyclic only, it is in the conjugation, students, it is in the conjugation. This double bond is shifted to here, it will get positive, it will get negative, so it is in the conjugation. Okay, it is in the conjugation only, it is in the conjugation. Sigma. See here, this is pi, sigma. Understanding? Here sigma there, sigma there. So it is not in the conjugation. Understanding, students? It is not conjugated. So not conjugated means which compound this is? It is which compound? It is non-aromatic compound. Understanding? It is non-aromatic compound. Non-aromatic compounds, aromatic, non-aromatic, which is least stable? Non-aromatic. Understanding? So that's why answer is which option? D option is the correct answer. Understanding? It is because it is non-aromatic. Understanding, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Lana. Thank you, students.